A lot of times we call probability the study of chances. What's the chance this will happen? What happened here? Next slide. My machine's acting funny here. Let me define a couple of things. Let's talk about event, because we're going to say what's the probability of this event happening. Event is any collection of results or outcomes of a procedure. An example, I might flip a coin and I said the event is the coin will land on head. You flip it, the result of that flipping the coin is going to land on head or tail. I might define my event as landing on head. I might define the event as passing the quiz or the homework. Might define the event as getting more than 3 inches of snow today. So the event is a collection of results. It could be more than like one result. If I'm studying like how much snow fell in Springfield in the last month, that'll be a collection of all the results of snow we got there and go through them there. Now, events can be broken down into simple events and compound events. So what's a simple event? Is any event that cannot further broken down anymore. Into simpler events. An example, simple event, someone is given birth. Boy or girl. Can't simplify that anymore. That's a simple event. Something maybe not so simple, like passing a test. Well, define what passing. 70 or more. That means that event can be broken down, someone scoring above 70 and below 80, between 80 and 90, 90 to 100. So a simple event, an event you cannot simplify anymore. This is the lowest level.
Like a 50-50, because it's either yes or no.
Yeah, yes or no, you can't simplify. A U.S. citizen, yes or no. You can't really simplify that anymore. You know? Other events you could simplify, like an example, the probability of being a Democrat or drive a Mercedes. You know, you can break it down, because that's first you think about Democrats, yeah, it could be Democrats, Republican, drive a Mercedes, Mercedes, not Mercedes, foreign car, not foreign car, and all that. So the event that's simple, you can't break it anymore. That's it. This is the lowest level, can't be simplified farther than that. That's it. Now, the other thing we're going to be talking about is called sample space. That's how many possible outcomes, or all possible outcomes. So sample space refer to all possible. I'll give you actually an example of compound versus simple events. All possible simple events. We call that the sample space. You list all the possible outcomes. I saw this in Dear Abby. It's supposed to be a true story. Duke University. There was a chemistry class going on, and 2 young men went to a party and missed the test, missed the final. They went to see the teacher, and the teacher said, you know, I had you guys before, so I know you're good students, so come tomorrow, I'll give you a makeup test. They showed up next day for the test and put them in separate rooms. The test, question number 1, I can't remember exactly the question, but a simple question. You take 2 hydrogen and you add to them 1 oxygen, what do you get? H2O, right? 5 points. Flip the page. Question number 2. Which tire was it? 95 points. That was their final exam. That was their final exam.
As one smart teacher.
Which tire was it? Now, if you told that if they really had a flat tire, he'd had them. You know, they're good students. But now, if they lied, they're in trouble. So knowing that teacher is clever, he probably, or she, I don't know if it's a he or she, probably drew a picture for them just to make sure you can't say, I don't know what you meant by which tire was it. So there's no guessing there. So looking at the picture of the car from the top, maybe it drew something like this. This is the front of the car. This is the rear of the car. So you can't say, I don't know. This is tire number 1, the driver. This is tire number 2. This is tire number 1. This is tire number 3. This is tire number 4. If you're looking from the top, probably put like a driver here, passenger there. So you can't say, I don't know what you meant. This is the driver. Now, when you look at that, there is actually 16 possible outcomes. That's what your sample space is. Let's give these guys some names. We'll call them Tom. And I don't know if they were men, women, so we'll go Tom and Lynn. Tom said tire 1, Lynn said tire 1. Tom will say 1, Lynn might say 2. 1, 3, 1, and 4. Or Tom will say it's tire 2, Lynn will say it's 1. 2 and 2. 2, 3, 2, 4. Hopefully the car has only 4 tires. Tom will say tire 3, Lynn will say 1, 3, 2, 3, 3, 3, 4. And the last possibility, Tom will say tire 4, Lynn will say 1, 4, 2, 4, 3, and 4, 4. So if I ask you the event is passing the course, that's not a simple event. Why? Because you can pass that test if you both answered 1 and 1, 2 and 2, 3 and 3, and 4 and 4. So passing can be broken down to 4 parts, basically. Tom can answer 1, Lynn can answer 1. Tom can answer 2, Lynn can answer 2. But if I say, what's the chance Tom will say 1 and Lynn will say 3, there's only one case. And that's it. So that's a simple event. 1 and 3 is a simple event, but passing is not a simple event. Because there are 4 different ways you can pass. It can be broken down farther, more. Passing means 1 and 1, 2 and 2, 3 and 3, and 4 and 4. By the way, if you're wondering what's the chance of them guessing, we'll talk about probability, which is the study of chances. You'll see in a few minutes, we're going to tell you the probability here of them passing this test or getting an A on it, because 95 points on that test on this question. If you get it correct, how many ways you can have the answer correct? 4 out of how many? 16. You have a 25% chance. Now, I don't know the outcome if they got it right or wrong. You can Google that, but that was in Dear Abby, an article about that. So that's the difference between simple event versus not simple event. That's your sample space. A lot of times we do the sample space, what we call tree diagram. What do I mean by that? I said, Tom is sitting in the other room going, oh boy, what should I answer? He can do 1, 2, 3. He can write any one of these 4 numbers, right? And if Tommy answers 1, you have no idea what Lynn is doing. Lynn could go 1, 2, 3, and 4. If Tommy put 2, Lynn still can do 1, 2, 3, and 4. 1, 2, 3, 4. 1, 2, 3, 4. How many choices does Tommy has to choose from? When Tommy trying to decide which one to write, how many choices does he have? 4. And for Lynn, how many choices does she have?
4.
What's 4 times 4? There are 16 different combinations that exist. That's how we figure out how many different combinations available. There are 16 different combinations that exist. So that's your sample space. How many different possible outcome could you have? Let's say you walk into a pizza place, and this pizza place saying, oh, we got combination. That's the only pizza we offer. And our pizza is so yummy, you have to get 3. You don't have a choice. You get to select 3 items in it. And you look at the menu and there's 10 different items on it. So when you're thinking about it, you're looking, how many choices can I go for number 1, for the first thing to put on that pizza? How many different choices do I have? You have 10 choices to choose from for the first item. And he says, you can't repeat. No repeat here. We'll talk about if there is a repeat. So if 10 for the first one, how many choices you have for the second one? There are 9 different things to select from. And for the third one, which is what? 8. So you actually have 9 times 8, 720 different choices you can make there. Now if we said, oh, you can repeat that.
When you repeat, would you be putting the stuff back in?
Correct. You can put like, you know what, I'll take pepperoni. For my second choice, I really like put more pepperoni, and for the third choice, put pepperoni again. So if select 3 again, and yes, repeat, you can. You can repeat if you want to. So for the first item, you have what? 10 choices. For the second item, you still have 10 choices if you want to. And for the third item, you have what? 10 choices, which is 1,000 different choices. Now I go to the gym every morning and I have one of those locks on my locker. It has 0 to 50 on it. And you can select the first number between, well, you don't have a choice, but they give you the 3-digit number already made for the lock. But if somebody wants to break into mine, and if they don't know what the combination, they're in trouble because there's 3 sets of numbers they have to go through. So the first number between 0 and 50, and I don't know if these locks you're allowed to repeat or not. Mine, there's no repeat on it, but I'm not sure. The ones you make your own, like bicycle, you can make your own combination. You can actually repeat that. Maybe I'll use that because I know my daughter has that for her bike there. It has 4 wheels, and it goes from 0 through 9.
I have one of those.
Yep, 0 through 9. And you can make your own number. There's 4 of them. And once you put them on the right combination, open it, and you can get your bike out. Since you can repeat, how many different choices do you have? 10 for the first one, 10 for the second one, 10 for the third one, 10 for the fourth one. What are your choices? 10,000 choices. So if somebody says, oh, I just happened to do it on the first try and open, unless you're the luckiest person out there, or you're lying. It doesn't mean it doesn't happen. The chance of winning the Powerball is what? 1 out of 175 million. How many people won last night? 3 different numbers. 3. There were 3 winners. 1 in New Jersey, 1 in North Carolina, and 1 in Texas, I think. So the chance of winning, very slim, 1 out of 175 million. We still had 3 winners. We probably sold about 100 million tickets yesterday, the last 2 days, you know. So that's the difference between simple event versus non-simple event. Another event might not be simple here, you know. Having 3 kids. You could have 3 kids. Oh, for my first, when you're looking at having 3 kids, you say, well, for the first child, it could be what? A boy or a girl. For the second child, could be what? Again, a boy or a girl. Doesn't matter what the first one is. Boy, girl, boy, B and G, and B and G. So if you're having 3 kids, these are your choices or your possibilities. You don't really have a choice. God gives us that. It's B, B, and B. B, B, G. B, G, B. B, G, G. G, B, B. G, B, G. G, G, B. How many choices? And G, G, G. 8. Why? 2, 2, and 2. Multiply them, that's 8. So if the event is having 2 girls and 1 boy, if you define the event as having this, 2 girls and 1 boy, that's not a simple event. It could happen by 2 girls and 1 boy. Let's see, what are there? There's this case, that's this case, and that's this case. If I say, what's the chance of having 3 girls? Can't simplify that. It's only one case. Can't be broken down anymore. Okay, I've been biting my tongue the whole time, not mentioning what probability is. So we're going to use the letter P to define probability. P here denotes probability. So when you see me write P of A, really what I'm saying, the probability of event A occurring. What's the chance that event will happen? The definition for probability, I'll make it in red. The probability of A is defined as the number of times A occurred divided by the number of times procedure was repeated. The bottom, by the way, I can write that differently probably. Divided by, I don't like this, procedure was, not war. Was repeated. Number of times procedure was repeated. I like to call that your sample space. Which is what? All possible outcomes. Outcome. That's what the bottom should be. Divided by all possible outcomes. Now let's go back to that 3 births here, having 3 kids. If I said to you, what is the probability of having 2 girls and 1 boy? The probability of 2 girls and 1 boy. Let's look and see how many times that event happened. 2 girls and 1 boy. See them? 3 cases, right? Divided by what? What's all possible outcomes? 8. 3 over 8. Is that 37.5? I think it's 37.5. What's the probability of having 3 boys? How many cases you have 3 boys? 1 over 8 in this case. Which is 12.5%. So if you're having 3 kids, your chance of having 3 boys, 12.5%. Your chance of having 3 girls, 12.5%. Now, if you like gambling and you go to the Mohegans and you decide, oh, I'm going to play the another slot machine. When you roll the dice, what is that? Roulette, thank you.
Well, let's go with the wheel.
That wheel, not the wheel. Well, we'll get to the wheel actually.
That's the one I like to play. So
Okay, tell me about that one, Nick. The wheel has, I think, numbers on it, odd and even numbers, and I think it has the 0 twice written.
Yeah.
So, if I remember, it does have 38 numbers on it.
Yep.
Is it 1 through 38?
Yep.
1 through 36? Something.
Oh, okay.
There are 2 zeros on it. It has 36 numbers plus 2 zeros. And what do you play on? Can you play even numbers?
You can play even numbers, odd numbers, the color.
Yeah, but zeros, you can't win on the zeros.
You can if you bet just.
Yeah, you can if you.
If you just bet the zeros. Yeah. But if you're just playing odd or even, zeros is neither. So the reason they have 2 zeros on them, if you have 36 numbers, that means there's 16. Besides this, there's 16. 38, there's 34. There's 17 and 17.
One of the zeros is a double zero.
Bigger, even?
No, just double zero.
But still, you don't win if it lands on it. So if I'm playing odd or even, there are 17 numbers odd, 17 odd numbers, and this has 17 even numbers. Zeros neither. So when you put your money at $5 is on odd, what do you win? $5, right? If it lands on odd? Because your chance of winning is not bad. They're not going to give you more than $5. So what's the chance you will win if it lands, if you say odd? Well, how many odd numbers we have on this roulette? We have 17 out of how many? 38. 17 out of 38, if you do the math, is below 50%. It is designed this way. That's what the 0 and double zero, to increase the chance for the casino. If it's 50-50, they're not making any money. So you have a 44.7% chance of winning if you do odd or even. If you decide just to play the zeros, either 0 or double zero, you said you can bet on both these, right?
You can, I think.
If you do this double 0 or double zero, they'll give you more money in that case. You put $5. If you win, they'll probably give you about $50. And the reason they want you to play that because your chance of winning that is very slim, which is what? 2 over what? 2 over 38. Which is you have a 5% chance. So they're not going to give you $5 for $5 for this and 5 for 5 for that because it doesn't make any sense. It's only 2 slots going to win here where 17 will win. You got a higher chance of winning here than here. So if you give them $5, you win $5. Here, because your chance is very small, they want to give you an incentive. Hey, you can win $50 or $100 on $5. Yeah, I'll put in the $5. I'll see. Oh, no, you didn't win. Sorry. Because your chance of winning is 2 out of 38 is 1 out of 19. That means you have to play it 19 times to break even. Or to win once at least. I was thinking about the table where you have the 2 pair of dice in your hand. I forgot. Craps. Okay. You can let 1 and 1, 1 and 2, 1 and 3, 1 and 4, 1 and 5, and 1 and 6, right? The other one could land 2 and 1. You have 2 of them. 2 and 2, 2 and 3, 2, 4, 2, 5, 2, 6. Could be 3-1, 3-2, 3-3. These are all the outcomes. 3-4. Assume one is red, one blue, so you know which one's which. 3-5, 3-6, 4-1, 4-2. I'm getting tired of this. 4-3, 4-4, 4-5, 4-6. 5-1, almost done. 6-1, 5-2, 6-2, 6-3, 5-3, 5-4, 6-4, 6-5, 5-5, 5-6, and 6-6. You win if the sum is 7 or 11. That's what you win. When the sum is 7 or 11. Let's see, where's the sum 7 or 11? To me, it looks like 1 and 6, 2 and 5, 3 and 4, 4 and 3, 5 and 2, 6 and 1. That's the sum equals what? 7. Any other ones where the sum is 7? Do you see anyone else? How about 11? 5 and 6, 6 and 5. So your chance of winning when you play crab there is what? 1, 2, 3, 4, 5, 6, 7, 8. You will win. Your chance of winning is 8 divided by 36. You have a very small chance. What's 8 divided by 36? Is roughly 22% chance. That's your chance of winning. All these games are designed not for you. They are designed to make money for the casino. I think the Mohegan Sun is designed to give them 26 cents on the dollar. The whole money that goes to the place, winners and losers and everything, when you do them, they get 26 cents on every dollar that was played in that casino. That's how it's designed. People say, oh, they don't want to give you the money. That's not the case. They want to give you the money because they want you to win so you can come back. You win, then you lose again. You get excited. I got to go back, take your friend. But it is designed for them to make 26 cents on the dollar. Yep. Sometimes we can calculate the probability if we do the event again and again and again and again multiple times, large sample, you can get the probability that way, and you're probably going to be close to the real number. For example, let's say you want to know what do you think of President Barack Obama asking for more support to fight ISIS? Let's say that was the topic. And you go and you survey 20,000 people all over the country to see what their reaction is. That's a large sample. That number probably going to represent, if it's done right, what the whole population is thinking about. So when you have large numbers, especially if the sample is really large, that number tends to be accurate measure. If the number is small, if you go ask 5 people, what do you think? What about if you ask 5 people who don't believe in war? It doesn't matter what Barack is saying, doesn't matter what the Congress is saying, the Senate is saying, they're going to say, no, we shouldn't do it. So when your sample is large, when you survey a large sample, that number tends to reflect what the population thinks, actually. So keep that in mind. If you're doing a study, you really want a large sample. What is considered large? Usually anything, I can tell you when there's an election to see who's going to be the next president, that sample size never exceeds 1,000 people. 1,000. And that will tell us how this 220 million people are going to vote.
Is it always like pretty spot on?
Usually within half a point to a point. Every once in a while you get somebody has an agenda. So a lot of times when you look at the election, they go, according to this poll, it looks like, let's take the next election. Let's assume it's going to be Hillary versus Jeb Bush. Hillary Democrat, Jeb Bush Republican. If I'm actually a Republican, I want to show the Republican are winning, I might actually go fudge the number a little bit there. But if you see 10 polls all indicating Jeb Bush is going to win by a point, there's a good chance Jeb Bush is going to win now. Because even if you were biased, if one of these polls is biased, the other 9 is going to pull you back there. So usually these polls are really accurate. They're on the money within 1 or 2%. You know, when they said, we think Barack can't run. We think Hillary versus John Kerry. It looks like Hillary is getting 30% of the vote. John Kerry is getting 28. They're probably on the money. It might be not 30, it might be 29, 27, 31, 26, but they're very close within a point from that. Yeah. Now, a couple of things to remember about probability. The probability of any event, doesn't matter what the event is, it will always be between 0 and 1. It will never be negative. It will never be more than 1. Never. If it's 0, that means this will never happen. Impossible. What is the probability that me, for those people listening to my video, I'm a male, me giving birth today, I said today, to a baby boy, 10 pounds, is going to be 0. It's not going to happen. I didn't say 5 years from now. God knows what medicine has down the road. If somebody approached me 5 years from now, Z, we'll give you $5 million if you carry that baby for a while, then we'll do a C-section, we'll pull it out. I'm in. 5 million, I'm in. You know, I can retire now. But today, that probability is impossible to happen. 1 means what? I am certain, 100% sure it will happen. What is the probability that any one of us will inhale some air, will breathe air in the next, if you're still alive, in the next 10 minutes, you will breathe some air? It better be 100%. Because you can't hold your breath. You can't go without air for more than, 2 or 3 minutes, 4 minutes, you're actually labeled as dead, brain dead. If you don't get oxygen for 4 minutes, you are brain dead. That's why CPR is crucial. Yeah. So if you're alive in the next 10 minutes, there is no way you can go without breathing. So the chance of this happening is 100% sure. This is impossible. Anything between these numbers. This is really important when you get to the big problems. You start doing some big problems, you end up with an answer of 1.5. That's a flag. Something is not right. You did something wrong. Your answer has to be between 1 and 0. It can't be more than 1. It can't be a negative number.
Wait, what's the chance we're going to die in the next 10 minutes?
That we don't know. Only God knows. I can't tell you that. I can tell you you're not going to give birth in the next 10 minutes, Mark. If you do, you better name that baby after me. Now, a lot of times you hear the terms certain, which I mentioned that, impossible, but there's also a scale in between them. So the scale that we use, possible terminology that we use, 1 means I'm certain. Let's go a scale like this. If the probability is 1, I'm certain it's going to happen. If the probability is 0, that means what? Impossible. It's not going to happen. What about if you have 50-50 chance? 0.5. I just gave you the answer. We call that 50-50 chance. If the probability is 0.5, it's a 50-50 chance. If the probability is somewhere around 25%, that's unlikely to happen. If the probability is about 70% or 75% chance, that's likely to happen. So these are some of the terms we hear a lot. Unlikely chance of snow today. That means there's 25% chance it's going to snow. There's 75% chance it's not going to snow. Chance of snow is likely to be high today. Likely, that means about 75% chance it's going to snow today. So we use these likely, unlikely. If we're not sure, it's 50-50. That's like guessing. You call somebody, you have no idea if they're Democrats or Republican. What's the chance they're going to be Democrat? 50-50. Well, we have independent too now. Maybe it's not 50-50.
We have a lot more than just 3.
Yep. Because Democrat, Republican, Independent. If it's in Springfield, what's the chance the person is Democrat? It's likely chance. We have way more Democrats in Springfield than Republican. If it's in Long Meadow, what's the chance the person is Democrat? Unlikely. Long Meadow is heavily Republicans. So if you look at the percentage of people in Long Meadow who are Democrats, probably below 25%. If you look at the percent of the people in Springfield who are Democrats, probably 75-80%, maybe even higher. So these are the terms we use. We also talk about complement of an event. Complementary events. So the complement of event A, we write that A with the bar over it. It's usually written A bar. Some of the new book, because to write the bar is difficult, they write that like this, A with a single quotation. That means the same thing. And what that means really, this one means it consists, Mr. S here, consists of all outcomes in which the event A does not occur. So for example, if I define event A as a coin landing on tail, what is not A? Heads, okay, head, what else?
The side.
Could land on the side, absolutely, yep. Not on tail. So it could land on that side. Once in a while you drop a coin, probably once in a blue moon it lands on the side. So that's what not A is. Everything but tail. If we define A as getting 80 or higher on a test, what's the complement of A? Not getting 80 or higher, which means what?
Getting 79 or lower.
Yep, less than 80. It's the opposite to that. Here's an example. We took a large sample. I'm trying to study the effect of cigarettes. What percent of the people smoke? And we did a sample. We surveyed 100, let's say 1,010 people. Does not be even 1,000. We'll say U.S. adults. We're only studying people in the U.S. So we're surveyed here. And 202 of them were smokers. Now I said the US because we do smoke less than other countries. Not all other countries. Some countries really heavy smokers. Some country probably more conscious than us. They don't smoke that much. You go to Sweden, they're into health. They walk a lot. They exercise a lot.
What's it say behind the record button?
202 people of them were smokers. Is that what it says? Yeah. So the question now, what is the probability a person we select is a smoker? Well, how many smokers do we have? 202 divided by the sample size. What was the sample size? 1010. Is that a 1/5? Which is 0.2%. I mean 0.2, which is 20%. So we can say 20% of the people in the US are smokers. What's the probability the person in the US, an adult, is not a smoker? Well, how many not a smokers?
Oh, 80%? Would it be non-smokers?
Correct. So to find that, we go, well, how many people out of the 1,010 not smokers? 808. Over how many? 1010, which is 4 over 5, and that's 0.8 or 80%. I didn't have to do actually the math here. I did the math to show you that. The reason I did that because I want to show you this equation. It says if you want to find the probability of not A, you can find that by taking 1 minus the probability of A. And I think that's what Joe said, 0.8, because he looked at this, that's 20%. It says 1 minus 20%, which is what? 80%. So the probability of not A is always equal 1 minus the probability of A. Sometimes you look at that equation, it looks a little bit different. They move this one to this side, the PA. If you move it to this side, it will look like this. The probability of A plus the probability of not A is equal to 1. It's the same equation, just looks different. So that's the complement. The probability of not happening equals 1 minus the probability of something happening. Maybe a couple more terms to mention while we add it. Unusually low number. The probability of winning the Powerball. Is 1 out of, you only buy one ticket, 175 million. That's unusually low. We call that unusual low number. The chance of that happening very slim. And sometimes you have the chances really high, unusually high number. For example, the probability of something happening, if we said the probability of you score more than 80 on the next homework on test, let's say it's 56 out of 58. That's unusually high. So if the number is really high, we call that unusually high number. If it's a small chance, that's unusually low number. With the O.J. Simpson, the case, if you remember O.J. Simpson was going to trial, they found, well, it could be. There's only 3 people in the world with that matching DNA. 3 in the world. That's unusually low. We still found him not guilty. Could only be 3 people in the world and said not guilty. To be high like this, 56 out of 58, Let's say, for example, we have 58 pregnant women and 56 of them gave birth to a boy. That's unusually high. It's 50-50. It's supposed to be half and half. So that's unusually high number. You can use sometimes the odd to figure the probability too. What do I mean by that? The Patriots have an odd of winning the Super Bowl next year to be 5-1 or 1-5. 1-5. That's the highest odd. Them and the Seahawk. They have 1-5. Right after the Super Bowl, the Seahawks were 1-5. The Pats were 1-7. Now it's back to 1-5, 1-5. Can we figure what the probability is for the Pats to win? The probability the Pats will win next year's Super Bowl. Based on this, they're saying one person saying they'll win out of how many saying no? 5. So altogether, how many of them were there? 6. And how many of them saying the Pats will win? 1. 1 out of 6. They have a 17% chance to win the Super Bowl again. As I said, right after the Super Bowl, their chances was the Pats will win, according to Las Vegas, was 1-7. That means their chance to win again, it's 1 out of 1 plus 7, which is 8, and that's 12.5%. So their chance increased by almost 5%. So that's how we figure, from odds, we figure the probability, because that means 1 saying yes, 5 saying no. Oh, I'm having too much fun. Okay, that's it for today, unless you have a question. So I will have a homework for